So this is an example on how to find stationary points. This problem is on page 637 and it's problem number 5. So the problem starts with the equation of the curve is given by f of x 5 plus 6x squared minus x cubed. The points R and S on the curve are the minimum and maximum points, respectively. Find the coordinates of R and S and justify your answer using calculus. So since they told us that R is a minimum point and S is a maximum point, that means that we have to find the critical values. In order to do that, we have to differentiate the curve. So I'm going to find f prime of x. The first term 5 disappears. The second term 6x squared becomes 12x. And the third terms become negative 3x squared using the power rule. Now, in order to find the critical points, I have to set the derivative equal to 0. Now, I could plug this into my calculator and figure out what the zeros are, or I could do this by hand. By doing this by hand, I know that the greatest common factor is 3x. That means I could factor 3x from both terms, which means that when I factor out 3x, 12x becomes 4, and negative 3x squared becomes negative x. And I set all this equal to 0. Now, how do I find what x is? I'm going to do 3x equal to 0, which means I divide both sides by 3, and I get x equals to 0. So that's one of my critical points. Then I'm also going to set 4 minus x equal to 0, which means in order to get x by itself, I'll add x to both sides, and that means x equals 4. And that means that I have two critical points, x equals 0 and x equals 4. Now, in order to figure out whether or not which one is my maximum point and my minimum point, I got to create a number line where 0 and 4 could be my stationary points. I'm going to use test points. That means 1 less than 0 and 1 more than 0. So 1 less than 0 is negative 1. 1 more than 0 is positive 1. I'm going to plug those test points into my derivative. When I do that, I have f prime of negative 1, f prime of positive 1. When I plug it into my derivative, I get that it's negative 15, and this is positive 9. What that means is that at negative 1, that means my curve is decreasing, and at positive 1, my curve is increasing. I'm going to do the same thing to the critical value 4. That means that I'm going to do 1 less, which is 3, and 1 more, that is 5. When I plug it into my derivative, f prime of 3 is 9. F prime of 5 is negative 15. That means that at 3, my function is increasing, and at 5, my function is decreasing. Now, how do I figure out which one is R and which one is S? So it says that R is a minimum. Now, we all know that minimums mean that our function is decreasing and then increasing. So this means that at the critical value at 0, this has a minimum point. So that means that 0 is actually part of R. And I know when I have a maximum, that means it's increasing, then decreasing. So that means 4 is S, which is a maximum point. So for my final answer, I know that R is located at 0, but I don't know what Y is. And I know S is my maximum point and the X is 4, but I don't know what my Y is. In order to find what Y is, I gotta plug these numbers into the original function. And when I plug it into my original function, I get that Y is 5, and I get that Y is 37. This is done. And this is what you would write as your final answer.